Hi everyone, and welcome to our video on the law of sines. So the law of sines is useful for us on non-right triangles or oblique triangles to help us find a missing side or a missing angle. So a missing side or a missing angle. And it has these two formulas. They're both the same. So sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. And then the other one is just flipping all of them up and down. Okay, so the sides are now on top and the angles are now on bottom. So notice the angles are accompanied with the trig function, sine, and then the sides are by themselves. If you're curious where these come from, so just real quick, we have an area formula for a triangle, so that's why this picture is here with the height. So notice the height's not involved in these boxed equations. But the area of a triangle, we did see, or we can see from somewhere. I think if we were doing these in order, we covered this at some point. Okay, so we have 1/2 AB sine C, 1/2 AC sine B, and 1/2 BC sine A. Okay, and it comes from that right triangle, the area. So if you are curious about that, we can try to break it down, but let's save a little time. And all it does, or all these come from is, well, let's just block these off. So notice we have 3 parts, 2 equals in between, and we're just going to multiply everything by 2. So if we multiply everything by 2, that would get rid of the halves. Okay, so those are gone. And then if we divide everything by ABC as well, so if we divide all of these by ABC, actually let's show it over there, divide them all by ABC, divide all by ABC, then we can see, okay, so that AB and that AB cancel. Look at that, sine of C over sine of C over C. Over here, the A and the C cancel, A and C, and we're left with B over sine of B. And then the last one, B and C cancel, sine of A over little a. So, and they just rearranged it. Okay, so that's where it does come from. Otherwise, let's see how it works. And again, either of these are fine. What this one does, let me mark it in blue. This form is probably a little better if we need to solve for an angle. And then this one's probably a little better if we're solving for a side. Okay, so, and it really, again, doesn't matter. So if you say, I don't want to know 2, then just stick to this first one. Okay, that gets the job done, and this is the way that we usually see it. The only reason I'm mentioning you could have 2 is it saves 1 or 2 steps if you do use one versus the other, depending on the case. All right, anyway, I'm going to use this first one on this problem. Okay, one other note. SOHCAHTOA. Oh, there's where this comes from, just a reminder. But SOHCAHTOA only is used on right triangles. So don't use SOHCAHTOA on these oblique ones. Same with Pythagorean's theorem. Those only work on right triangles. Law of sines will work on non-right triangles. All right, so let's find this information. So it says solve the triangle. When it says solve the triangle, they want us to find all the missing sides and missing angles. So I'm just going to call this angle A, which makes the opposite side of it little a. I'm going to call this angle B, which makes this 16 little b. And then down here, I'm going to call that angle C, which makes this side little c. And to solve a triangle, I usually just set up a table with their angles and sides ready to go. And I think this should be enough room. I'm just boxing it. And then I will put in what I currently have. So I have 15 degrees for angle A. I have 135 degrees for angle B. Angle C we can find instantly. So we do have the rule. Remember that the 3 angles in a triangle add up to 180 degrees. Okay, so A plus B, so 15 degrees plus 135 degrees plus C is 180, which gives us 150 plus C equals 180, and then C would be 30. Okay, so instantly we can solve. So if we ever have 2 angles, we can always get the third right away. So there's our 30. All right, now that I have my 30 degrees, I mean, we could put it into our picture too. I'm just putting the answers that I'm finding in blue. I do have one side that I didn't mark yet. Okay, so it was 16 feet. Okay, so we found one part already. We need to find the two missing sides. All right, so we see, oh, it's not a right triangle, so it's probably a law of sines problem. So we'll just set up our law of sines. Sine of A over A equals sine of B over B equals sine of C over C. And then now we'll sub those in. So we have sine of 15 degrees over A equals sine of 135 over 16 equals sine of 30 over C. Okay, and then now that we have this set up, we want to choose one of the ratios that is completely full of information. So the middle one for sure. And then we'll just separate it and set it equal to one of the others. So let's get A first. So we'll do sine of 15 degrees over A equals sine of 135 over 16. And then we want to solve for A, so we'll just cross multiply. So we'll have 16 sine of 15 degrees equals A sine of 135 degrees. And then I'm going to leave the trig functions with their angle in them until I get my letter by itself. So I am going to divide each side now by sine of 135. So we have 16 sine of 15 degrees over sine of 135 degrees is our A. Okay, I'm going to cloud that because if we can't use a calculator, this is one way that we might write the answer. Now, sine of 135, though, we could do. So on our unit circle, sine of 135 is the square root of 2 over 2. Okay, so that means we can do a substitution. So we have 16 sine of 15 over square root of 2 over 2 is A. Okay, so I'm solving it as far as I can without a calculator, and then we'll plug in the calculator. Okay, so what we have here, so we just need to simplify. So this is a little extra simplifying. We would times both sides by 2 to get rid of the complex fraction. So we'd have 32 sine of 15 degrees over square root of 2. Is that A? Sine of 15 we can't do, so it's not on the quoted unit circle, so we just leave it alone. And then until we are ready for a calculator. But one last step, that square root of 2 they're not going to like too much, so let's rationalize both sides by square root of 2, multiply. And then we can simplify 32 square root 2 sine of 15 degrees over 2 is A. And then one last time, we can say, oh, that 32 and that 2 would simplify to be 16. And then square root 2 sine of 15 degrees is A. Okay, so this is as far as we can go without a calculator. So I just wanted to work that practice because often trig classes you can't use a calculator, but we would want to go as far as we can without one. Here we are. And then now let's actually plug it in. Okay, so 16 square root 2 sine of 15. And make sure the sine is out of the square root, just like that. Okay, so 5.8, we'll do 2 decimals, 5.86. Oh, it says right exact value answers. Okay, so that was the clouded one. Okay, so we will do both. Okay, so the square root, or 16 square root 2 sine of 15. So that's the exact value. So remember, exact values is as far as you can go without a calculator. But let's go ahead and use the calculator here. So 5.86 to see them both. Chances are we need a calculator anyway on a lot of these problems. Okay, so there's that side. And then we need to find side C. So that's what these law of sign problems are. So it's mostly now a repeat. So I'm back to here. Again, I'm going to take that middle because that had all of the information for one of the fractions and set it equal to C now. So this is for C. Or not set it equal to C, set it equal to the fraction that has C in it. So sine of 30 over C. Okay, and then it's pretty much the similar steps that we just saw. So we cross multiply. So we have C sine of 135 degrees equals 16 sine of 30. Now both of these we can do. Okay, so, well, but first let me divide. Let's say divide the sine of 135 over. So 16 sine of 30 degrees over sine of 135 degrees. Okay, so again, if those, so I'm clouding this because if these angles were not on the quoted unit circle, say you had like 27 degrees and 131 degrees, then that's what we would leave it as if we can't use a calculator. Okay, but these ones we can do because they are on the unit circle, so we would say, well, this becomes 16. Sine of 30 is 1/2. Sine of 135 is still square root of 2 over 2. And then we can simplify. I would again multiply both top and bottom by 2 because of the fractions. Okay, so that means that 2 and that 2 cancel, and that 2 and that 2 cancel. So we'd have 16 over square root of 2. And then we can rationalize it. Okay, so 16 square root of 2 over 2. And then looks like we can simplify one last time. 8 square root of 2. Okay, and that one simplified all the way. So let's write it in here. So we've got 8 square root 2. And that would be in feet. I didn't mark the other one. That one was also in feet. I'm going to put it there. And then if we do want to see it in a decimal, let's see it. Okay, so 8 square root 2 is 11.31. Okay, there we are. Okay, so we got them all. One nice thing once you have the decimals is to compare the angles with your sides. So the smallest angle should always match up with the smallest side. So 15 degrees matches with the smallest side. Yep. The biggest angle should match up with the biggest side. Yep, 16 is the biggest out of those three. And then the medium angle should match up with the medium side. So it's a quick way to let us know if we're wrong. So if one of those is mixed up, we know we messed up somewhere. Okay, but there is the law of sines. So the law of sines, a lot of repeats. Kind of get used to that there with the law of sines. Okay, but that's it. Thanks for watching. If you have questions, please let me know.